The slope-intercept form of a line, or linear equation, is y equals m times x plus b, where the m is the slope and b is the y-intercept. As a quick refresher, the slope is the change in y, or how much we went up or down, over the change in x, or how much we went left and right. The y-intercept is where the line crosses the y-axis, which is also where x is equal to 0. If we have y is equal to 2/3 x plus 1, this linear equation is in the mx+b format, so we're in slope-intercept form, which means the coefficient of x, the 2/3, is our slope, and the 1 is our y-intercept. To graph this line, the first and easiest point we can get is the y-intercept, which again is where x is equal to 0, so we'll be at 0, 1. To form a line, we need two unique points. So to get the second point, we can either plug in for x and get a y out, or we can use the 2/3, which is our slope, to move along the graph to find the second point. Recall that the numerator of the slope is the change in y, and it's a positive 2, which means we would go up 2. And then the change in x is a positive 3, which would mean to go to the right by 3. So our second point would be here. And now we can draw the line. Now, what if we have y equals -3 x minus 2? We're still in slope-intercept form, but this time the slope is not in a fraction form. So we can create that by putting the -3 over 1. And now we have the change in y up here and the change in x below. We can get that first point quickly using the y-intercept. In this case, it's a -2. So therefore, our first point would be at 0, -2. And we'll use the slope again to get a second point. Now this time the slope is negative, but keep in mind, the negative value can apply to either the numerator or the denominator, but not both. Otherwise, we would have -3 over -1, and that would become positive 3. So if we attribute the negative to the 3 on top, that's the change in y, that means we have to go down 3 from our current spot, 1, 2, 3. And then the change in x is a positive 1, which means to go to the right by 1, and we would be right here. And now we can create the line. What if you wanted to attribute the negative to the 1 instead of the 3? We can do that. Let's start at the second point that we got. If we have a -1 in the denominator, that's the change in x, so we would have to go left 1. And then, since the 1 was negative, the 3 was positive, so we would have to go up 3 from there and end up at the second point. So in other words, we're either going right and down, a positive move and a negative move, or we could also say we're going left and up, negative to the left and positive going up. To help make sure that your line is at least in the proper direction, keep this in mind. Anytime a line is going from the top left to bottom right, like so, your slope is always going to be negative because we either had to go right and then down, that's positive and negative, dividing those becomes negative, or you went down and to the right. On the other hand, a line that goes up and to the right has a positive slope because we're either going up and to the right to get to the new point, or down and to the left, which would be two negatives, and when you divide that, they become positive. So the slope would be positive. You should also know that a horizontal line, perfectly straight left and right, has a slope of 0, while a perfectly vertical line, straight up and down, has an undefined slope. And we'll cover those in a different video. Now, what if you were told that the slope of a line was equal to 1/2, and you were given 1 point on the line of 4, 5, and you needed to find the equation of this line in slope-intercept form. So how would you do that? Notice that the slope-intercept form has 4 unknowns at the moment, y, m, x, and b. And for any single equation, we can only have one unknown, so we're going to have to plug in. The most obvious would be the slope. So we have y is equal to 1/2 x plus b. We still have 3 unknowns. However, we were given a point on the line. So what we can do is plug in the 4 for the x and the 5 for the y to solve for b. Now we have 5 is equal to 1/2 times the x, which is 4, plus the unknown b. Let's simplify. 5 is equal to 1/2 times 4 is 2. We still have plus b on the end. Now we just need to subtract 2 from both sides, and we find out that 3 is equal to b. When you're asked to find the slope-intercept form of a line, once you have the slope and the y-intercept, then you replace the x and y with the variables again. So in other words, the final result will no longer have 4, 5 in there. It would look like y is equal to 1/2 x plus 3. Let's try this example. What if we were given a point 5, 7, and this time instead of having the slope, we're told that the y-intercept is equal to 3. We're going to use the same idea where we plug in 5 and 7 for x and y respectively, and we can throw the 3 in for b, and that will allow us to solve for m, the slope. Our y value is 7, so we have 7 is equal to m, which we don't know yet, times x, which is 5, and then plus the y-intercept, 3. First, we'll need to subtract 3 from both sides. We get 4 is equal to the slope m times 5. Now we just need to divide 5 from both sides. And finally, we get that m is equal to 4/5. Once more, we'll rewrite the equation with x and y as variables. So we have y is equal to the slope, which we found to be 4/5, times x, plus our y-intercept, 3. Let's do one more example. This time we're given 2 points, -2, -1, and -4, 2. Clearly this time we do not have a slope or an intercept, but since we have 2 points on this line, that's all we need to find the slope. Recall that slope is equal to change in y over change in x, which can also be thought of as y2 minus y1, the difference between the y's, over x2 minus x1, the difference between the x's. If I label -2 as x1, then the -1 paired with it must be y1. In that case, -4 is the x2, and 2 would be the y2. Let's first get the slope. y2 in this case was 2. We're going to subtract y1, which is minus a -1, over x2, which is -4, minus x1, which is -2. 2 minus -1 would be 2 plus 1. That gives us 3. And then -4 minus -2 would be like adding 2, and that would give us a -2. So our slope is 3 over -2, which is the same as -3 over 2. Again, the negative can apply to either the 3 or the 2, just not both. Now that we have the slope, we can find the y-intercept by plugging in one of the 2 pairs of numbers into the y and x. Just be careful not to mix and match. If you use -1 for your y, you need to use -2 for the x. Let's use that point. Our y in this case would be -1 is equal to m, the slope, which is -3 over 2, times x, which was -2, plus b. We'll simplify. -1 is equal to -3 over 2 times -2 would equal 3, still plus b. And now we just need to subtract 3 from both sides, and we find that -4 is equal to b. We have all the information we need to write the equation of this line in slope-intercept form. So it would be y is equal to the slope, -3 over 2 times x, plus b. But notice the b is negative, so adding a negative is like subtraction. We'll just write it as -4. Thanks for watching. If you found this video helpful, please smash that like button and subscribe for more videos.